Welcome back, everybody, and in this next part in the RBD series, we're going to be exploring some more techniques that you may need to know as shots come up. We'll be doing this shot in this earthquake scene. The techniques that I'm using can be used in a variety of shots in the industry, so I figured this would be a perfect addition to this series. All right, to get started, I'm just going to drop a geometry here. We're going to keep the scene really simple and just focus on the RBD, and we'll call this ground. I'll do a box. Let's go ahead and kind of similar to what we did in the last video, we'll just say 0.25 here on the Y, copy parameter, paste relative reference, and divide that by 2. And then I'll put this in the negative axis. And there you go, you'll see it's now my new ground. And honestly, this is probably a little too big for this one, so we'll say 0.15. There you go, that'll work better. We'll make it 10 in X and then 5 in the Z-axis. That'll look better. And we'll do the tearing right across the board right there. The next thing I actually want is a line. So we'll drop a line here. The direction we want is going to be in that X direction. So we'll say 1, 0, and then I could take the parameter here in that X and make that my length. So paste relative reference. So let's see what that looks like. There you go. I have it. Now we have a few issues, right? They're not really properly set up. So we could do something very similar to what we did here on the Y-axis. We could do this on the X-axis. So we can copy this parameter, go to the origin, paste relative reference, and then divide that by 2, and then type in negative so that it lands in. So negative of this length divided by 2, we'll put it right there in the middle. But you'll notice, or on the top, I kind of want this in the middle. So I'll just copy parameter here and paste relative reference, negative. So we drop that down as well. Okay. And I guess we could divide by 2. So we could actually just technically, well, make it even faster. Delete this channel. Go back to 0 for now. And just copy this channel here. Paste relative reference. So I have this nice line here. These are just 2 points, but we'll use this to drive our fracture later. But more importantly, what we're going to do is isolate the middle. So to do that, I'm going to do a sweep. And to increase the resolution of this sweep here, using a square tube, we're going to go ahead and resample this curve. So let's resample. And we'll just, as you can see, when you resample, it actually does a good job of creating this nice geometry here that we can use. But let's go ahead and maybe increase this width a little bit so we get this nice area of fracture. We can drop a VDB from polygons, and there we go. The issue though right now is you'll see it doesn't actually complete. So we come back up here to the sweep, go to the end caps. We need to give it some end caps. So let's do single polygon for this. We don't need a lot of resolution there. And let's go and increase this resolution to maybe 0.05. And then we just convert this back. So let's say convert VDB here. And I'll just go to polygons. Cool. Now I can throw a Boolean fracture down. So this will be my cutting object. This will be my main cutter. And there we go. Now the problem is the VDB actually shrinks in a little bit. So if I go to an exploded view, you'll see what happens, right? So we do actually happen to have geometry here on the side that I don't necessarily want. So let's fix this real quick. We could just do a simple transform. And on that x-axis, we will increase the scale by, let's say, 1.1. And we'll have now clean geometry here. Is it the end of the world? Not necessarily, but we get the 3 pieces that we want: the left, the right, and the middle. Or left, right, middle. Okay. So a couple of things we want to set up here in the Boolean fracture though. We want to give it a name. We're going to call this, in this case, we'll just call active. So we'll say active underscore. All this looks good. I do want to copy cutting surface attributes. Let's go ahead and give this some UVs here. So let's just do a UV unwrap. I'm not going to spend a lot of time on the UVs here, but if we click on our image icon here, you'll see we have UVs. I also want to give this box UVs, so we'll just copy this over. And so you'll see here in the exploded view, we have UVs now. All right, let's split this up now. We'll do a split. And we'll go ahead and select. I'm going to hover over my viewport now and press 9. And let's go to attributes, name. And so now I can select these entire pieces, and I want to select this middle piece here. And that's where our entirety of our fracture is going to be. So we'll hit enter. and you'll see it's active too. And we'll call this null. Out, inside in this case. We'll copy this over. We're going to use both. We'll actually use the outside to control the edges. But for right now, I just want to deal with this. Now, we have a very clean cut, so let's add a little bit of destruction to this at this point. So before the unwrap, and let's go move this up a little bit higher. I want to add a little bit of noise, and that's kind of the whole reason why I went into such a high resolution here. So let's add in an attribute noise. There we go. Now we don't have any normals, so we'll just add that in now. So normal, before, and now what we can do is noise along vector, and we'll do P. I'll do a Worley cellular, and I'll just play with this, play with the size. So we get this nice kind of rocky look to it. We're going to do a concrete fracture for this demo. That's good. Maybe we'll layer another attribute noise. You can also use a mountain node now that you've added normals. So, but I like to layer my noise. Make sure you use offset. So we'll do P, noise along vector. And I'll do another Worley, but this one will be maybe a little bit smaller, and then make sure you're offsetting, right? You don't want the same noise on top of the same noise. We'll offset this way. There we go. Cool. All right, that's something. Let's take a look at what we got. We'll look at the exploded view now, and you can see we have a much better fracture. Now, in this video, we're not going to cover doing detailed custom fractures, so we're just going to use the RBD material fracture here. So let's go ahead and do that. We'll flip this back into VDB. And a trick I like to do here is do a bound. So we'll do a bound. And this will actually be more prevalent in later videos when I teach you guys how to do your own custom fractures. But we'll do a little bit of padding here. So I'll say 0.1, 0.1, 0.1 across the board, 0.1, 0.1, 0.1. We just want it slightly bigger. And then let's do a VDB from polygons. And we'll say 0.05 here for now. And then we'll do a convert, or rather, sorry, we'll do a scatter. Now, we can't scatter on the surface, right? Because what's going to happen is it's going to scatter this way. So we want to come up here and switch to density. And in fact, you can even turn off the surface at this point, and there you go. You'll have points now that are inside. We have a lot of points on the surface, but that's going to be good. That's what we want, actually, for now. But we'll play with this later. Let's just go ahead and get the RBD material fracture going. If you've been with me for any stretch of time, you'll know I actually do not like this node at all. But for this video or this technique, this is going to do the job for us. It's going to be a little bit on the slow side, especially at 1,000. So let's lower this to 500 for now. And let's just hit RBD material fracture. Okay. I got to do a couple things here. Let's go to this first concrete fracture. And let's label this level 1F, and then we'll go to the second one. We'll call this level 2F. And on this first one, I want to input points, and this is going to slow it down. Okay, here we go. We have a fracture here. We get rid of the image. You can see it's quite random between the two fractures being combined here, and I've kept the scatter points up a little bit. Haven't really touched any of the settings, but I want to get a little bit of control. I want smaller pieces towards the middle, and they get a little bit bigger towards the edge. So we could do that by modifying our scatter. Take this line right here and actually use it, and create another resample with the curve view attribute, or we could just create a little bit of jaggedness to this. So let's bring this down here. We'll call this break direction. Let's resample. Instead of maximum segment length, we'll do maximum segments. And that will leave us with 11 points. So 0 to 10, that's 11 points. So we could do an attribute noise here. And we'll do P. You'll see that it does a good job. And then I'm going to do 1 through 9. So we'll do 1 through 9 on the points, and then we only want to do it in the X and Z axis. And in fact, you can probably get away with not doing it in the X axis at all. Here's the problem though. Even if I go to 0 centered, you'll see that it will push my values there. If I go min max, we'll start to get values that's going across. But even then, because this is switched to add, it's not going to yank on enough points to keep it from going only in one direction. So I have a little bit of a workaround for this. We can try and do the noise along vector again. The vector isn't properly set. So we'll do an attribute wrangle here. On points, I'm going to set a new normal at n equals set 0, 0, and then I'm going to try the z-axis because we want to move in the z-axis right here. So 0, 0, 1, we're going to initialize it. And you'll see that if I enable these two back here, they still stay in the z-axis because it's following that vector. And one thing that we can do is I can say fit rand at pt_num, and then say +7 for that offset. And we'll say 0 to 1, and we'll say -1 to 1. So we'll get a little bit of randomization there, and there you go. A little bit of a hack that I do to get around the positive nature of this, and you can see they start to go out. And I can say channel float offset here. And we could play with this, and you can see we can get different shapes. Okay. This is obviously too big. We don't want that big, and we want to shrink the element size. We want this to be pretty crazy. I think that works. You can play with it. Now the line is already where we want it to be. Okay. Well, we can do a couple things. We can work off the scatter that we already created and pull points towards this line using a point VOP, or we could just use this to run our noise. So I'm actually going to use this to run the noise rather than this bound right here. But if you want resolution to work in your favor, you can use both. So for this first scatter, let's just drop this to, let's say, 25 for now. Really, really low. Okay, really low. And then for this next one, we'll do a point replicate. And let's get rid of that, and you'll see what's happening. It's creating points along the along that curve. However, I want to resample and add even more points here. I also want to add a curve view. And let's go ahead and say 0.05 here. So we have a lot of points to deal with this. After that, let's do an attribute wrangle. And this is where we'll add a little bit of the randomization to our fracture here. So we're going to go ahead and initialize that curve view into a variable. We'll say float curve equals at curve view. And I want a ramp right now that I could drive into a parameter to control my emission attribute from the point replicate. Okay. It could be anything. We're going to call it amount. So we'll say f at amount equals curve, just so you can see what actually happens here, and then we'll change that. So let's go generate from attribute. I'll switch this to 1 for now, and we'll say amount is what I created. And there you go. You'll see what's happening is 0 to 1, we're getting more points emitted here. But if we remap this curve into a ramp, so we'll say channel ramp, remap, curve, which already is 0 to 1. I can say hill, and you'll see we'll have more points in the middle and less points at the end. What I actually end up wanting to do here is not a ramp at all, is an actual noise based off this curve. And we could keep it in the ramp, but we want to add noise based off this curve 0 to 1. So we'll say rand, okay, curve, and you'll see now we're getting a little bit of randomization. Okay? And I can play with this. Doesn't matter where I put this hill. Now I'm just kind of creating, okay, I want more noise there, I want more noise there. And then up here, points per amount, we can run this procedurally so that it matches up with this. And we could say for every 25 points here, we're going to emit 1 here. Or we don't have to do that at all. We can just play with this. Let's change some of the shaping though. So for the shape, I want to go to a circle, and I want it to lie flat on the ZX plane. So it lies flat like that. Let's go ahead and look at our box here. the width of it, and I want to make sure that I have quite a few points concentrated here towards the middle. And let's go ahead and just say uniform scale here, and we'll add some noise. Now this noise is going to push them up in the y-axis. I think that's going to be okay, but just know that you're going to have some points flying off that won't contribute at all. All of this looks good. Let's go ahead and merge these in and see what our new fracture layout looks like. And you can start to see that we have more and more points that are showing up towards the middle. If we play with this replicate, and we'll say 1, there we go, more points towards the middle. And let's just go ahead and say 2.5 here. And this is going to kick up our fraction. We start to have a nice little break line. We're going to use constraints to control how these pieces break based off their rest length. But I'll click this up even more. Cool, looking good. Go to detail, edge detail, and then interior detail. This is where we're going to start to see some artifacting happening because we did do a boolean, and so not all of our edges over here are robust. So if you see artifacts pop up, don't panic. We'll fix it. Don't worry. I think we may have just got lucky, but you're likely going to see a lot of artifacting come up. We do have artifacts. Let me see. Well, let's just take a look at what that looks like. So we'll say exploded. View. I think I got really lucky this go around, although I'm only using default settings, so as I play with these. But for the most part, it actually works. But let's say you do have artifacting. You'll want to go to no polygons. It's going to create terrible geometry, but in later videos, I'll show you how to fix that. Okay, so we have the basic fracture now. And in fact, there's one more thing I want to do. I'm going to go to the chipping here and enable some chipping. We just want that extra resolution along these edges that could really go a long way into showcasing just a really good looking scene right out the gate. Now, another thing also to be aware of at this stage in the game, our UVs are going to be quite terrible along the edges. We can go and fix those with the for loop, but at this resolution, that's going to take a while in this video. If you're curious to learn more on how that works, feel free to reach out to me and I can sit down and show you how that works, but we'll go ahead and keep moving along at this stage. All right, we need to actually start building our constraints. The first thing we'll do, let's go and prepare our low-res geo by assembling it. One other thing I forgot to do is we want to make sure that our name is accurate. So if we come over here, you'll see that we have active2 _0 dash. I don't like using dashes. I like using the underscore. Give that a second. And there we go. So I like using underscores. Just it helps me to stay consistent. When we come down to the assemble, we already have the name. So all we have to do is just create packed primitives. And then we can do a null at this point and call this out RBD fracture. Okay, let's go ahead and build that constraint network now. I'll delete this null. I'm going to use a glue cluster. And there's a visualizer built into this that we can use. As you can see, we have these clusters now. Turn off random detach. We don't want any random detaches. I don't want any pieces in the middle that I don't have control over. We're going to do a slip strike fault here, which means one side is going to move very quickly to the right or left, where maybe we're going to keep one side still. It's kind of like the San Andreas fault here where I live in Los Angeles. So I want to kind of make these a little stretched out. And to do that, we're going to lower their size here in the Z. And we can go even lower than that, say 0.5. And so they look a little stretched. We can play with this, make them bigger, and then maybe just play with that a little bit. This one's not as important because we're very flat, but that looks good. And let's go ahead and work off of that. You will notice that we get an internal strength here of -1. So you'll see that we'll have some strengths here that are 1, some strengths that are -1. But it allows us to split here. And I could say, hey, at strength equals -1. Okay. And there we go. So now we're splitting. We'll do this in an RBD constraint properties. And we'll call this the glue constraints. And then over here, we'll do another RBD constraint properties. Make sure that's in this way, by the way. So into the constraints. And this one, we'll call this soft constraints. I'm going to use soft constraints for this one, and then in a solver inside of my .NET, I will play with these soft constraints based off of the data that it gives us. So I like lowering this down to 10. Let's turn on the strength variance here, and we'll just keep it as glue. In the soft constraints, we want to switch this to soft, and all this looks good for now. We'll keep the stiffness at 10. We may play with that later. All right, the only thing left now is to merge these together so that they're back together, and then we'll do a null. And we'll clean this up so it's a little bit faster. So attribute delete. Point attributes, we'll just write what we want to keep here. I want to make sure I keep the name. That's important. And in the primitive attributes, I want to keep the name for the constraint, the tag, the type. I do also want to keep the strength. Okay. Rest length and stiffness, damping ratio. We want to keep that, making sure anything else here. All this looks pretty good. And we'll just hit delete non-selected at this point. And so you'll see the colors go away. And we'll call this out interior constraints, which is a huge clue about what we're about to do next, which is create exterior constraints so that these are pinned to the actual side pieces. So if we come up here, remember, we have this split here, and we have this outside. And for this, we're going to do a couple of things. So the first thing I want to do is prepare this and actually create a small little Voronoi fracture so we can have points inside that will work with the interior pieces here. So let's go ahead and just do an ISO offset. And what we can do to keep this a little bit more under control is we can split, and I'll split by the piece names. So ISO offset there. And then we'll do an ISO offset on this side. So we'll say 100, do a scatter. And I only want like 10 pieces, maybe 25. To see this better, let's go to a darker background. There we go, that'll work. And then we'll do a Voronoi fracture. I don't need a lot of detail on this. These are not actually gonna do anything for us. So. And then let's just copy this whole thing over. And let's go ahead and say Voronoi, and then ISO offset. Okay, and make sure that this is switched to append. And this one switched to append. And let's do underscore piece underscore, and then underscore piece underscore. So that's that, and there's that. And then we can play with the seed if we want. Again, not that important. Let's merge them together. And if I look at this attribute here, you'll see that the names should all be different. They're not gonna be any duplicates because we have active 0 and then we have active 1. That's why it's really important that you set your naming, you start naming as early as possible. Okay, so there we go. What I wanna do is I'm gonna take this assemble node here, and we're going to drop an add node. This is the assemble on our interior fracture. But we're gonna drop an add node here and delete, so we just have our points. And we're gonna create constraints here along these to these points as well. And so I'll drop an assemble, create packed, and drop an add here just so that we can see what we're about to do. Okay. We'll do a merge. This one we should also delete. And so I'm going, like I said, we're going to create points from here inside to kind of hold these pieces together. Drop a color here after the add. Come on. There we go. And we'll say this one is red so we can see that. Okay. And let's use a connect adjacent pieces. And we'll just drive this up, and you'll see that these are actually grabbing that red. We'll see if that's enough for us right now. Okay, I'm going to do an attribute promote now, and we'll move CD up, so point to primitive. All right, the problem that we have at this point is we have all of these extra constraints that will come in. And so I want to blast these out. So to do that, I'm just gonna do a split instead of a blast. And we can say, since in order to get red, so if we go to the geometry spreadsheet, we go to our primitives here so you can see it. In order to get red, you have to have 0 in green and blue. You can see right here is red. And so I can write an expression here that says at cd.g, and we'll do this on primitives, by the way, is less than 0.5. And it will split off those reds. We can even say, all right, 3. Actually, it doesn't even matter. Let's say maybe 9. Yeah, okay. So we can split off those primitives. Now, we have some that are still on the inside, though. So, and to kind of cross-check these, you can see that, yeah, we need to actually keep those ones on the inside here. So we'll say 0.9. Because these are the ones that are the most important ones right here, those constraints. So we have that split. And so we'll do null here. Okay, so you can see it, and there we go. Now, instead of a null, or we'll use that null, but let's do an RBD constraint properties. Whoa. There we go. And what we'll say is these will be glue. But I'm going to keep their strength insanely high for right now. And then we can play with that later. I'm not even going to add variance. We'll call this out exterior. Okay, now we want to add a little bit of animation here. And I like to add that animation between the assemble and the add. So let me just start a new one here. We'll do a transform. And this should work. Sometimes it creates an issue and we'll have to fix it later. But the way I like to do this is actually come up here and transfer a couple attributes here. So the first one is the normals and the name, just in case we need them later. But we do need them right here. So if I expose this, you'll see that I get those names here. So the ones that I actually want to use should be this entire side here. So we have to create a containing group for this one on this active. So I believe that is going to be on this tree. So before it comes down, we can do either a group. You could do this as a group, or I could do an attribute wrangle here on the primitives and say s at big equals s at name. And we're copying that name constraint over to a new or that naming convention over to a new attribute here. So then I can call that attribute up here big, and then we can transform by big. So we have this active 0. And what that will allow me to do, if you take a look at this, is I can move this from side to side and not have to worry about the other side. So let's go ahead and just maybe go to frame 4. And I want to set some keyframes here. We'll just move in one axis for now. But you'll see that moving in multiple axes will do a lot for you. And I just want to move this way very slightly. So we'll say, whoop. There. Okay. So this is what we got. That's very, very fast. Yeah, it's a little fast, a little far, but we'll work with that for right now. Let's take a look at our constraints though and see what that looks like. And you can see the constraints, unfortunately, are moving, and that might pose a problem for us down the line. But we'll approach it as it comes up. Okay, so we have our edge constraints. The last thing that I want to do is take, after this assemble here, a null, add an attribute wrangle here, and we want to set some attributes on our pieces. And we're going to say I at active equals 0 because we do not want them to simulate. I want I at animated. I'm actually going to do 0 because we're going to use the deforming attribute. So I at deforming equals 1. Okay. And then we'll call this out edge geo. Call that black. I just move this down here so I have it. And now we pretty much have all of our pieces in play. We have our RBD fracture. I have interior constraints. I have exterior constraints. And I have the out edge geo. We're going to see if they work. So let's go ahead and drop a .NET for this one. So we'll do a .NET work. We'll call this RBD sim. Let's dive in. Let's set this up. Rigid, can't spell, rigid body solver. We need gravity. We need that RBD packed object. Make sure we're naming. We're going to call this geofracture. Let's go to split build at this point. You can use the games or you can build your own UI. Let's go ahead and go into here. So geofracture there. And then let's start adding these in. So let's say RBD fracture. And we'll keep the attributes. Everything here is good. I want to add some mass here. I want to lower the bounce here to 0.01. That looks good. And if I were just to hit play, the whole thing is just going to fall, right? Pretty uniformly. So just be aware of that. Let's go ahead and start setting this up. We'll do a merge here. We'll do RBD packed object. This one's going to be edge, geo. Let's go grab it. I'm going to go ahead and say overwrite the attributes here. So we have deforming. Let's just hit play. So it's not active and it does move. There it goes. So that's what we want. And you could see how good this fracture looks even in low res. So, all right, let's start getting some of our constraints in. So the first one, we'll do a constraint network here. We're going to do it up in the geofracture area. And we'll do the other one down here. Okay, so we'll do glue, constraint relationship, glue, constraint relationship. We'll also need a soft constraint relationship. So bullet soft constraints, merge. Put those in, and then let's go grab our interior constraints. And if I hit W, there they are. White is soft, red is the glue. We'll play with that here in a few. Okay, let's go ahead and add our other constraint network now. And this one, we will grab our exterior constraints. And we'll do a glue constraint relationship. And we'll leave that. And let's just see what we get. And you can see out the gate, it's looking pretty good. Now, our soft constraints are kind of going crazy. We're going to play with those here in a few. Let's give this a different color. So I'll go to guide options and we'll say, I don't know, cyan here so we can see it better. Let's go darker. And you can see that we're having a little bit of issues with those constraints on the side, but most of the action is going to happen in here anyways. So let's play with it. So the first one I want to play with is going to be the soft. So we'll lower the stiffness because this is 10 times that 10 up there. So we'll just go 1, 1, 1. I might actually do a damping of 2. And then let's hit play. Let's lower this right now to 250. It's what I found to work the best with the value of 10 up there. And there they go. They start to break, but we still have some chunks. We can always play with that later. But this soft constraint is going to be the bane of our existence. So to fix this, we're going to have to run the sim and then bring the sim again into a SOP solver and then run the sim again. I know, confusing, right? So we'll do a SOP solver here. We'll call this break soft. Put this into the constraint solver here and let's dive in. We're working off relationship geometry. And let's go ahead and bring that sim into here. So I'm going to do a DOP import. For that DOP import, let's go grab that output. For the objects here, so we'll look at this. I want all the objects actually. So we want, actually I only want the geofracture. We only want the interior. So there we go. Okay. And then I can do an add here so we can see this better. And delete that. And if I hit play, you'll see that these points are simulated because it's running that entire sim. And now we're going to bring it here and we're going to run a quick check to see how far these pieces move. So I can split by a few things. We'll say split and we'll take the soft. So now I only have the soft constraints. And we're going to create an attribute on this tree, copy it over here, and then we'll break these points by whatever our parameters set here. So let's do a time shift so we can find a rest attribute. Okay, so we'll say find rest, and we'll say delete channel on that first frame since we know that nothing should be moving on that first frame. Okay? And then we'll do an attribute wrangle here, and we'll say v at rest equals v at p, right? Because we just created a new rest attribute there. This is a hack. This obviously isn't the rest position node, but this does work, right? And so now I'll just do an attribute copy. And we want to do it match attribute by the name. And we're going to do rest. So if I come in here now, and I highlight this geometry spreadsheet, and I do P and rest, so we can see the difference. Okay, and I hit play. You'll see the rest attribute stays the same, but these are different. And now we can measure distance between each other. The distance from here to here. And when that distance hits a certain threshold, we'll break these points. All right, so let's set attribute wrangle here. And let's initialize our rest. So we'll say vector rest equals v at rest. Vector position equals v at p. Okay. And then we'll say float dist equals distance rest position. And then we can just do a check. We'll say if the dist is greater than channel float thresh, remove point 0 at pt num. Okay. We'll change this here in a second, but I just want to show this to you. And then we'll say, hey, when the distance here gets greater than 0.1, they break. Look at that. How cool is that? Okay. So we'll say 0.25. And instead of removing, we'll go ahead and write an attribute. So we say I at kill equals 1. And to see it, we'll say at cd equals set 0, 1, 0. And we'll say, hey, when they go green, they're going to die. Okay. So let's see what that looks like. There they go. Cool. That looks really, really good. Okay. So now we should be able to delete our soft constraints. So, but we're actually not going to delete them. We're going to delete them here. We're going to delete them over here. So now we can do another attribute copy. Okay. And we're on only the soft constraints here at this point. Let's take a look at that. And we'll say kill. Match by attribute. We want to do that name attribute. Okay. And then we could do an attribute wrangle here. Also still in points. I know we're looking at primitives right now, but we're going to do this in points. And say if I at kill is greater than 0, remove point 0 at pt num. So instead of destroying it here, we destroy here. And now this is what we get. Give it a second, and boom, our soft constraints start to just disappear on us. So that's going to be set here in this thresh. We can write a tool to do it, but for right now, this will work just fine. One last thing I need to do is I need to actually merge in the actual glue constraints, or else all of our constraints will delete, and we don't want that. And let's go take a look at what we got now. Hit W and hit play. And now you've got an earthquake effect. Or ground separating, ground cracks. We can animate those constraints breaking forward. This is just such a useful trick that you can use today to get this nice looking material. And look, by the way, at our glue constraints here, holding together, and gives us this nice jagged edge. We could do the same over here, but if you remember, I did mention that we are animating our constraints here. So we can probably manually break those using the same technique here in the break sim. There's one last thing I want to show you. I don't want this video to get very long, but I want to show you the actual high-res version. So we'll do a transform pieces here. And in here, on the output, we'll do a dot import now into here. Okay. Take this output into that dot import. I only want to bring in that geofracture. And let's go ahead and do this on our high-res now. Okay. Actually, it should be from this. Should be from an assemble. So we'll copy this assemble. There we go. And do it from the high res now. Okay. Cool. Let's hit play. And now your high res pieces with your chips and all that little detail is there. And the only thing left to do is just merge this back into your out edge geo. And you now have a nice earthquake fracture. And hopefully it's giving you guys a little bit of inspiration on some of your RBD effects that you could be using today. We've gone into 8 parts now in this series. I'm hoping at this level you guys are now confident in maybe tackling your own shot. Let me know what you guys think in the comments below. Be sure to check out our Discord server. We are constantly having discussions. I give you feedback on your work. I also include exclusive information here, maybe videos and tutorials that I actually would not post on the YouTube channel. You can also have an opportunity to network with industry artists. With that said, I'll see you guys in the next video, and remember, always be creating.